Hi everybody, I'm Héctor Moreno from the Universitat Politécnica de Valencia in Spain, and I'm going to present the work entitled Irrigation-induced soil salinity as a limiter of soil quality in a semi-arid Mediterranean growing area. The study that I am going to present has developed in Alicante, a province in the southeast of Spain, and more specifically in the area of La Pedrera, an area that encompasses different municipalities of the Bajo Segura region. It is an agricultural area where citrus and horticultural crops are grown, with a climatic character between arid and semi-arid. Near the study area, we find the Torrevieja Lagoon, a natural area, and a few kilometers away, we find the Mediterranean Sea. This area in the past was abandoned with a variable orography, and in 1973-74, the National Institute of Agrarian Reform and Development of the Spanish government studied to promote it as an agricultural development zone. For this, the government commissioned a study from the university where the USBR methodology was applied to 29,000 hectares. Thanks to this development, a practically abandoned area has become an important agricultural area today. However, this increase in the agricultural area has caused a series of problems in the soil, and in order to study them, this work has been proposed with the aim to determine the evolution of soil quality during 45 years according to the USBR land evaluation systems. For this, 28 soil profiles were defined as control and were sampled during 4 campaigns, evaluating the properties of the soils to later determine their quality and classify them based on the 6 evaluation classes of the USBR. As main results, we can say that in 1974 the profiles were classified as suitable for cultivation, giving rise to the construction of the reservoir with an exact amount of water. The problem was that during the following years, in addition to the severe drought, the cultivate area doubled, with a shortage of water resource that led to the construction of illegal wells at great depths that extracted saline water of poor quality. That water salinity caused a salinization of the soils and the aquifers, because higher doses of leaching began to be applied. This is reflected clearly in the electrical conductivity of the soils for those years. For example, it can be seen how there is a notable variation in salinity compared to pH or carbonates, which, depending on the parent material and not including human action, did not suffer practically any problems in that period. After that situation, government noted that they have to solve it and started to use water from the treatment water plant. This caused the salinity to decrease rapidly, and the crops could recover, returning areas already abandoned due to salinization. Regarding the last evaluation in 2019, an increase in the soil salinity can be seen due to an increase in the agricultural area and again to irrigation with groundwater, reflected by the presence of chlorine and sodium in the soils. As you can see at the beginning, 71.4% of the soils were classified as Class 1, the one with the best quality for irrigation, noting that in 2019 there is no any point classified as such class. The evolution of soils classes has not followed any pattern over the years, as you can see. As main conclusions, we can say that soil evaluation is necessary for monitoring agricultural areas in order to maintain and improve the soil quality. We have to take care with the over-exploitation of resources in area with the deficit of this type of resources. In arid and semi-arid areas, salinization and salinity due to the bad management of practices can generate loss of soil quality. And it's necessary to evaluate soils before the startup of the farm, and some quality indicators must be controlled constantly in order to know which is the state of our soils. Thank you very much for your attention, and if you have any questions, you can contact me.